Hello everyone. Today let's solve the Leetcode problem number 91, decode ways. So what the question says, you have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. So 1 they have mapped to A, 2 they have mapped to B. Similarly, so C it will be 3 it will be mapped 3 will be mapped to C, D will be mapped to D. 4 will be mapped to D, and following and so on. 25 finally Y, and 26 finally it will be mapped to Z. Basically they are considering from 1 to 26. They are mapping from 1 they have started and they have mapped to A, right? It will go on until 26. 26 is nothing but Z, we can see. However, while decoding the message, you realize there are many different ways you can decode the message because some codes are contained in other codes. So 2 and 5 versus 25. Yeah, this is fair, right? Some codes are contained in other codes, 2 and 5 as 25 versus 25. For example, 11106 can be decoded into 1110 6 or 11 this one 11 10 6. Yeah, this is fair, right? This is AAJF, this is KJF. So this is fair. The grouping 11106 is invalid because 06 is not a valid code. Only 6 is valid. Okay, this is fine. Note there may be strings that are possible to decode. Given a string S containing only digits, return the number of ways to decode. If the entire string cannot be decoded in any valid, then we have to return 0, they have said. Again, if the entire string cannot be decoded, we have to return 0. They have asked us to return 0, right? This is fair. Let's consider the example 1. S, they have given 12 within the strings and output is 2 because we are having the 2 ways to decode 12. One is A, B, nothing but 1 space 2 or L directly, 12. So this is fine. And example 2, 226 they have given within the string. There are 3 ways. So one is BZ 226 or 226 or 2 space 2 space 6. So this can be decoded in this way. Here in example 3 we don't have any way. So the output they have given as 0. So this is fair. Let's write the code and try to understand with the example 1 so that you can check for the similar way for example 2 and 3. Let's first initially write the code and try to understand with the example 1, right? So initially what I'll do, let's make use of the dynamic programming for this. So what I'll do initially, let's check if the current index I is already computed and stored in the memo. If yes, we will return the stored value to avoid recomputation. So for this, I'll just make use of the if condition. If I in memo, return memo of, if it is already stored, will be returning the iterated value of the memo. Next, if the character at index I, so the particular character at the index I is 0, then we will be returning 0. Why we will be returning 0? Because 0 cannot be decoded on its own, right? So we cannot decode the 0 on its own. So we will be returning 0. If the character at index I is 0, we will be returning 0. This is simple. Again, I'll just make use of the if condition. Nothing but iterated value of the yes, if it is equal to 0 within the strings they have given. So I'll just take within the string itself is 0. Then what we'll do, we will return 0. This is fine. Next, if I is at or beyond the last index. So if I is at or beyond the last index, we will be returning 1. Why we will return 1? Because there is only one way to decode the remaining substring. So directly we will return 1. Again, I'll just make use of the if condition. If I greater than length of the S, length minus 1, right? Sorry. We will directly return 1. Why we are returning 1? Because there is only one way to decode the remaining substring. So that's why we'll directly return 1. Next, we will memorize the result for the current index I. How can we memorize the result for the current index I? One is we will memorize for the the number of decodings by considering the current character alone, nothing but I plus 1 and I plus 2. Either we can memorize the result for the current index I by summing the results of I plus 1 next character and the I plus 2, right? Only if the combined value is less than 27. It has to be less than 27 by the character starts from 1 and it ends at 26, right? Again, I'm telling you, we are memorizing the result for the current index I by summing the results of I plus 1 and I plus 2 only if the value is less than 27. Why the value should be less than 27? Because we are starting from 1 and this one, it is ending at 26. The Z is ending at 26, right? So that's the reason. In this case, I'll just come here. In my case, I'll just give iterated value of the memo equals num decodings. Let's make use of the recursive function. So here, let me give this yes I plus 1 as I have said and memo. One more thing, what we need, what we are concatenating, what we are adding. Yeah, yes, so iterated value of the yes plus again s of I plus 1, right? So of I plus 1. We are checking whether this is less than 27. It has to be less than 27. If it is less than 27, then what we are doing, again, let me make use of the recursive function. S of this one we'll be considering. Nothing but in the in place of I plus 1, we'll be making use of I plus 2. So I plus 2, memo. This is fair. This will be, or we will be returning 0. So here they have asked, just give me a second, this one. So if the entire string cannot be decoded in any valid way, we have to return 0. So else we are returning 0, right? We are just making use of the ternary operator in this case. So this is fair. Next, what we will do, do one thing. We will return iterated value of the memo. Nothing but we are returning the memoized result for the current index I. That's what the result, right? We are returning nothing but the memoized result of the current index I. So I'll just give return memo of I. So this is fine. Let me format the code. Let me hit the submit. So I is not defined somewhere, the line number 2, right? So just give me a second. Let's do one thing. Along with the yes, let's consider we can initialize I to 0, or I'll just consider here itself I equals 0. And also I have forgot this one, memo. I'll just consider the empty object. So yeah, I forgot to initialize these things, right? I equals 0 and memo equals this one, empty object. So yeah, now this works completely fine. So let's try to understand the code by taking the example. So here, let's consider this example, right? Initially, what we'll do, we'll start with the num codings. This one, num codings of S initially is 12. You can see here the example 12, and I is nothing but 0. So I is 0 and memo is initially this one. You can see here empty object, nothing but memo is this one, empty object. So I equals 0 and S of 0 is equal to 1. I equals 0. Here we can clearly see we have initialized I to 0, right? I equals 0 and S equal to S of 0 is nothing but 1. So the index is not memoized yet. So we'll move to the first branch. So we consider decoding 1 alone here. So now we will consider decoding 1 alone. So we will recursively call num decodings of, this time it will be 12, 1 and this one, right? differences. Now the I will be 1. So what we'll do, this index is also not memoized yet. So this index also is not memoized. Next we will go to the second branch. So what we'll do here, we consider decoding 2. So now it will be num codings of 12, 2 and this one. Empty object, right? So now I is equal to 2. Initially it was 0, and initially the first branch it was 1. For the second branch it is I equals 2, which is at the end of the string. So here we can see it is at the end of the string, right? So we are returning 1. Why? Due to this one. If I is greater than s dot length minus 1, we are directly returning 1 here. So you can check here. So what we'll do, we will return 1. Means there is only one way to decode the string from index 1 onwards as B. So this one is 2, we know that it is B, right? So this is 2, nothing but B. B, I'll just, in my case, I'll just come here. B, I'll write this side. B, that is nothing but 2 here. So we now know that there is only one way to decode the string from the index 1 onwards. So as B, this one we got. Next, we will return to the first call. The recursive call at I equals 1. The recursive call at I equals 1 will, what it will return basically, just give me a second. It will return 1 itself. The recursive call that we made at I equals 1 will return 1. We now check if 12, both the characters together, 1 and 2, we are considering 1 and 2 together now. 1 and 2 together, that can be decoded as a single character, right? So since 12 is less than 27, here we'll come here, 12, it is less than 27 basically, right? As 12 is less than 25, we call num decodings of 12 to this one. We have considered 12 to this one again. We will be calling this one again by 12 is less than 27 as we know. This returns another one, right? We will get another one. Why? Due to this condition. If I greater than s dot length minus 1, we are directly returning the 1, right? So representing the decoding L, directly we'll get L. This will be 1, 2. This time we will get L, nothing but 1, 2, right? So finally what we can say, we sum up the results from both branches, nothing but 1 for B from 2, this one as well as plus 1, nothing but for L from 12, that is nothing but 2, right? This 2 is stored in the memo of 0 and returned as the final answer. So we have got one thing we can observe. I forgot here. A we should have considered, right? This A I didn't show. Basically, I went with B directly. A should have been 1 and B should have been 2 and L we got, obviously. So now what we have got, the string 12 can be decoded in 2 ways according to this one, right? So AB, we'll consider this one. AB, nothing but 1 space 2 we get. And L will be 12 directly. That we saw how we got, right? So these two things, the exact same thing that we have got here. So we have 2 ways now. One is AB, 1 space 2 and L 12 directly, right? So here they have explained the same thing. Explanation, 12 can be decoded as AB 1 space 2 or L of 12. That is nothing but L equals 12 directly, right? So the output is 2 because we have 2 distinct ways, right? With 2 distinct ways, we can decode the 12 as one is AB, that is 1 space 2 or L of 12 directly. So yeah, this is it. And you can check the same thing, same steps for the example 2 as well. So what will be the time complexity and the space complexity? So the time complexity would be big O of n. Why the time complexity is big O of n? Because each index is visited at most once due to memoization. We are visiting every index only once. Why? Due to the memoization. We are memoizing after visiting the particular index, right? So it results in the linear time complexity, nothing but big O of n. I'll just give big O of n. So what will be the space complexity? Just give me a second. The overall space complexity would be big O of n as well. Why the space complexity would be big O of n? Because we are making use of the memoization object, nothing but this one. If you can see in the example also we saw, this is nothing but the memoization object. Due to the space complexity would be big O of n due to the memoization object memo, this one as I've showed, that stores the result of each index. So result of the each index will be stored in this itself, right? So that's why we are making use of this object. And we are also making use of the recursion stack here. You can see this one and these 2 lines. You can clearly see we are making use of the recursive functions, right? Num decoding. So that's the reason that overall space complexity would be big O of n as well. So I'll just comment these lines. Let me hit the submit again. So yeah, this works absolutely correct. So this is it. Thanks for watching, guys.